Hey everybody, welcome to homework 16. This is your last lesson in this pre-calc companion lab, so that's reason enough to celebrate. In this lesson, we're going to simplify a complex rational expression. So what that is when sum and or differences of rational expressions appear as the numerator and or denominator of a quotient. The quotient is called complex rational expression. So for example, this one and this one. Basically, when you have a fraction and a fraction. So notice that you have your main fraction here. Here's the numerator, here's the denominator. But within the numerator, you have another fraction. Within the denominator, you have another fraction. Same thing here, you have a fraction and a fraction all within a fraction. Notice that it does say and or. You don't have to have it in both. So if you have 1/2 in the top and that's all over 4, that's still complex because you still got a fraction and a fraction. So to simplify complex rational expressions means to write a rational expression reduced in lowest terms. This can be accomplished in 2 ways. And by the way, this complex rational expression can also be called a complex fraction, which I think this is actually mostly what it's referred to. That's how I usually refer to it, but those mean the same thing. So here's our method 1 and our method 2. And in example 1 here, we are going to simplify the complex fraction using both methods. So let's just jump into example 1. And in this first one, we'll do method 1. And then in this one here, same exact problem, we're going to use method 2. So step 1 is to simplify the numerator and the denominator of a complex fraction so that each has a single fraction. So notice I'm adding 2 fractions here. I need 1 fraction. Notice we are doing a whole number plus a fraction. I want to simplify that to just a fraction. So you could technically put in your calculator 1 divided by 3 plus 1 divided by 2, and you're going to get your answer. But as you can see on the next page, they're not always going to have just numbers. A lot of ours are going to have variables in it too, and you can't do that in your calculator. So we're going to do this by hand so you get the process of whenever you have variables in this expression. So in the top here, you've got 1/3 plus 1/2. Your LCD would be 6. And if you don't know how to find your LCD, which is the same as LCM, really, I'm going to include a video in the link in my math lab so that you can review it. I'm not going to review how to find the LCD or how to find the LCM. So if you don't know how to do that and you don't know where I'm coming up with those numbers, either watch the video I'm including. It's a video from CPM2, or just Google LCD or LCM, because again, they mean basically the same thing, and figure out how to do them. But I'm not going to be doing that in this video. So once I figure out my LCD is 6, that means I need to write both of these fractions over 6. So to get that 3 to a 6, we're going to multiply by 2. So 2 times 1 is 2. And to get that 2 into a 6, we multiply by 3. So 1 times 3 is 3. And so notice here, if you reduce these numbers, 2/6 reduces to 1/3. 3/6 reduces to a half. So I'm just writing these in equivalent fractions. Okay, you've got to do the same thing in the bottom. And in the bottom, my LCD is 4. If you only have 1 fraction, then that's what your LCD is. So I'm going to multiply 2 by 4 over 4 to get 8 over 4. And again, 8 over 4, what does that reduce to? 2. And then plus that 1/4, that's good. So now I can add them. So 2/6 plus 3/6 gives me 5/6. 8/4 plus 1/4 gives me 9/4. And so now I have a single fraction in the numerator and denominator. So now we're to step 2. Perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the complex fraction. So we keep that 5/6. We're going to change this division to multiplication and multiply it by the reciprocal of the bottom, which is 9/4. And it says to simplify if possible. I'm going to simplify before I even multiply. 5 and 9 can't reduce, but 4 and 6 can. So divide them both by 2, and this becomes a 2, this becomes a 3. And now multiply straight across. 5 times 2 is 10. And 3 times 9 is 27. Okay, so that's method 1. Not the friendliest of things, right? I show you example 1 in case you like it more. I personally like method 2 so much more. In method 2, step 1 is to find the LCM of the denominator of all rational expressions that appear in the complex rational expression. Multiply the numerator and denominator of the complex rational expression by that LCM. So again, I'm not going to teach that. Watch a video, Google a video to find out how to find the LCM. But in this one, you're looking at every one of these denominators in any part of that fraction. Between 3, 2, and 4, my LCM is going to be 12. And let me do this in a different color. Okay, once you figure out what that LCM is, what you are technically doing is multiplying the top by 12 and the bottom by 12. I think it's just easier to just multiply each thing by 12. That way you can cross-reduce things. You don't forget anything. So I'm multiplying everything by that LCM. Now, if you choose that LCM correctly, what's going to happen is I should lose every single fraction besides the main one. So 12 times 1/3, I'm going to cross-reduce, and that turns into a 4. So 4 times 1 is 4. 1/2 times 12, I'm going to cross-reduce, turn that into a 6. All over, 12 times 2 is 24. And 1/4 times 12, cross-reduce, turn that into a 3, so that's a +3. And so now, simplify the results. 4 plus 6 is 10. 24 plus 3 is 27. I think that is 100 times easier than what we did right here in green. Okay, so I'm going to be using method 2. I say that, and then we're going to use method 1, okay? These two are really the same things. And so when it's just a fraction and a fraction and a fraction, when you're not adding fractions in the top and adding fractions in the bottom, it really doesn't matter which one you use. So if I use method 1 here, okay, in 1 minute, I'm going to kick my dog out of the room real quick. Come on, Sam. Go. Bye, Sammy. Okay, sorry about that. The reason why method 1 isn't so bad here is because step 1 is to simplify the numerator and denominator of the complex fraction so that it's a single fraction. Well, that's already done. So we're already on step 2 at this point. So step 2 says perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the complex fraction. So this becomes 16 over 5x times 5x over 4. We're flipping that one. That's the reciprocal. So now these cancel, and I just have 16 over 4, which is just 4. Okay, now we're going to use method 2 for the rest of these. Okay, going all the way down. So on B, find out what the LCM is. And because I only have one thing in the denominator, that's exactly what your LCM is. So your LCM is x plus 3. So multiply every term by x plus 3. Your x plus 3's are all going to cancel. And now what am I left with? I'm left with 7 in the top. Nope, I'm left with x in the top and 7 in the bottom. Okay, so we could have done the same thing on this one here, multiply top and bottom by 5x. They cancel and you're still left with 16 over 4. Okay, on C, again, in both of these, the only denominator is x, so that has to be your LCM. So multiply everything by x. So I'm multiplying the top by x and the bottom by x. X times 3 is 3x. 4 over x times x, your x's cancel, so that's just a minus 4. X times 1 is x. These x's here also cancel, so then plus 7. We got rid of all of our fractions in the top and bottom. That's the whole point of that LCM. And then that can't be simplified anymore. So that's it. Okay, here your LCM is between 2x and 4. So the thing to multiply everything by to get rid of that fraction is going to be 4x. So multiply all terms by that LCM. And hopefully all of our fractions will cancel. If they don't all cancel, we pick the wrong LCM. So here we can cross reduce. That's going to become a 2. So I've got 2x times 1. Here my x's cancel. So 3 times 4 is all I'm left with. So plus 12. All over, my 4's cancel. And so I'm left with x times x plus 3. And really, we could keep it just like this. A lot of times it's actually easier to leave it in this form. But if you wanted to multiply that x out, that would be, if I could write a decent 2x plus 12 all over x squared plus 3x. So those are equivalent. I'm pretty sure my math lab will take the first answer. And like I said, a lot of times it's actually easier to leave it in that form. And then lastly on E, we've got y squared, y, x squared, and x. So my LCM here is x squared, y squared. So we're going to multiply this by x squared, y squared, this by x squared, y squared, and both terms in the bottom. Okay, so let's get to canceling. We've got y squared and y squared, so those are gone. So I have x squared times x to get x cubed. 1y will cancel, so this y on the bottom cancels, and that 2 cancels. So I've got 1 times x squared y, so that's x squared y, all over. My x squareds cancel here, so y squared times y is y cubed. And then 1x will also cancel, so I've got 1 times xy squared, and so that is xy squared. Okay, now I think this is correct, but I can factor out something, and so let's see if that helps me simplify anymore. Okay, in the top, I've got x cubed and x squared y. I can take out an x squared in both of those. So that leaves me with 1x plus y. All over. In the bottom, we've got y cubed plus xy squared. Both terms have 2 y's, so I'll take out a y squared. And that leaves me with y plus x. So it's a good thing we checked because these do cancel. Even though they're in different orders, if you're adding, those are the same, right? If you do 3 plus 4, that's the same as 4 plus 3. And so those cancel. And so my final answer is x squared, y squared. Now, just to kind of be clear, if that was x minus y over y minus x, those aren't quite the same, right? If that's 4 minus 3, that's 1, but then 3 minus 4 is a negative 1. So those would cancel, but it does leave behind a negative 1. So plus is okay, but minus is a negative that it will leave behind. And that's all I got for this lesson. I probably should have said from the very beginning, you're going to have a lot of like simplifying like this in your calculus class. And a lot of calculus teachers, especially if you have Nunley, he will tell you that a lot of times students struggle with the algebra, but the calculus is easy. And that's true. Students will struggle with things like this, but then they know how to take the derivative of something. So this is to help you with the algebra that students seem to kind of struggle with. So I definitely should have started with that because I don't know how many of you guys have made it to the end of this to know why you are actually learning this, but that is why we are doing it. If you have any questions, please let me know, but this is your last lesson. Don't forget you do have an optional lesson that will replace your lowest grade. So if you have a 0 for something or a 50 for something, if you do the optional assignment, that will replace your lowest score. But if you're happy with your grade after this, then it's been a joy having you in class, and I wish you the best of luck in Calc 1 and beyond. Bye, guys.